All right, so in this video, the first thing I want to talk about is what this actually means. So we have an unknown number in here, which we call x, and I'm interested in its distance from 0. So I'm looking for essentially a number whose distance from 0 is 3. In other words, I'm looking for a number that is 3 spaces from 0. Now what you have to remember is a number line goes in 2 directions. You have your positives and you have your negatives. So we can definitely agree that 3 itself is definitely 3 spaces from 0, but so is negative 3. So x could be two numbers, negative 3 and positive 3. Both of those have a distance of 3. All right, so it's the same thing here. So if you notice, I have a little bit of extra stuff in the bars here, but the concept is still the same. I am interested in generating a distance of 5. Now there's two numbers that are 5 spaces from 0, both 5 and negative 5. So if that's the case, then I need to make sure that my x value helps me get a 5 or a negative 5. So I'm essentially going to take what's inside my starting problem, set it equal to 5, but I'm also going to set it equal to negative 5 because both of those are a distance of 5. So I can either use 7 for x, or I can use negative 3 for x. So that does seem a little weird, I know, but if you plug it in, you'll see that for yourself. So if I substitute 7 in for x and check my answer, and substitute negative 3 in for x, the absolute value of 7 minus 2, well, that would become the absolute value of 5. And then here you would get absolute value of negative 5, and both of those result as a 5. So that's why we have to take into account there's two scenarios. There's the positive numbers, but then there's also the negative numbers. Both of those are a distance from 0. So then what are you going to do when you get these really nasty problems? So there's a lot of stuff here. It's a little bit harder than just looking and guessing what could work for x, right? So we have a series of steps to help us get through this jam. The first step is you want to isolate your absolute value bars. And if you know, isolate means to be alone. So the rule is, unless you're in the bars, you need to leave. So notice how that 3 and that 6 are outside of the bars. They're not in between them. We need to remove them from this side of the equation. Now you are not allowed to add 6 plus 3. The reason being is 3 is supposed to be multiplied by the bars, but you're also not allowed to distribute the 3, so you're kind of in a jam. So you want to focus on removing. Right now, we are adding a positive 6. So to undo that, we want to subtract a positive 6 from both sides. Again, knowing I'm not allowed to distribute, now I need to undo multiplying 3 by the bars. So when you have something that's side by side, there's a multiplication operation going on. To undo multiplication, you have to use division. So we'll divide both sides by 3. So now I'm going to get the absolute value of 2x minus 5 has to get me 1. So what that means is I want to generate distances of 1. So whatever's in this bars, I need to make sure that the distance of the final number in the bars is 1. So what we're going to do is we're going to set the inside of our bars equal to both the positive and the negative version of whatever's on the right. I call that breaking into cases, case 1 and case 2. So for case 1, we want to get a distance that comes out to 1. But case 2, you could also get negative 1, which also has a distance of 1. So again, I have to use both the positive and the negative version of the result, because both 1 and negative 1 have a distance of 1. And then we go through and we solve each of these separately. So we'll get 3 for this one, and then 4 divided by 2 gets you 2 for the second one. So the answers to this problem are 3 and 2. So it's very normal to get 2 answers because there's 2 directions you can go on the number line, positives and negatives. Both of those are measurable and have distances. So we're just going to practice those steps with the 3 examples you see. All right, bars are isolated, so step 1 is done. Step 2, you're going to break this into case 1 and case 2. you set the inside of the bars equal to positive 9, but the inside of the bars could also equal negative 9. Both of those have a distance of 9. So r could equal negative 3, or r could equal positive 3. Now there is a shortcut to writing this if you don't want to write the 3 twice. It's a very common symbol you see in Algebra 2. We use this little symbol and then write 3 once. So this actually means both positive and negative 3. So when you see that, it means, oh, the answers to the problem are positive 3 and negative 3. All right, let's try it again for number 2. So we can see that 3 is being multiplied by the bars, but we're also adding 8. So when you solve this, you always want to subtract first and save division for last. It'll make your life easier if you do it in that order. So we subtracted 8. Now we're going to divide by 3. And now we have our bars isolated. Right, this is now where you want to set up case 1 and case 2. So case 1, the inside of the bars actually do get you 24, or the inside of the bars gets you negative 24, which then the bars will convert to positive 24. So it looks like you're going to get 3 and negative 3 again. So I'm actually just going to be a little lazy and use my fancy symbol. And then we do one more. All right, so this one's a little trickier. So the first thing you want to do is maybe slip a little 1 in here. You have to remember that there's always a 1 in between a minus sign and a grouping symbol, like bars or parentheses. So what they're doing is they're multiplying these bars by negative 1, and then they're adding a 3 to it. So you want to undo that by subtracting 3 on both sides. And then just bring down everything else. Then we're going to divide both sides by negative 1. And we want those bars to be alone. All right, so therein lies the problem we want to solve. We want to generate a distance of 11. The way we do that is if the inside comes out to 11 itself, or the inside could come out to negative 11, which also has a distance of 11. And when I solve these, I'm going to get 17 over 8, and I'm going to get negative 5 over 8. So there's your 2 answers for that problem. So you want to get used to the fact that you're going to have 2 answers for 99% of these problems. All right, in our next video, we want to talk about some trick questions and then maybe tackle a challenge problem.